is, it's a large plant burn rate. This is time of a year run in the number of batches that can be run in a format of 40 days per batch. Then you have what I like to call nearly a fixed cost level that is a museum's level. You need to have something in order to have the light on and the water in the right quality, and you have to do all of this. This is before you run anything. What did I do? And then is the variable cost. The variable cost increases with the number of batches run. But if you do then run batches, then here's an example. If you run a batch for 24, for example, in a 6-pack plant, then these batches cost something like 1.5 times the annual burn rate. And if you calculate this over the gram, then this is a quite expensive one. If you, however, use the entire plant capacity, then you are at nearly 200% of the burn rate of the museum, but then you get a lot more. So there is a possibility to run these plants more or less efficiently, depending how many runs you can house in there. And worldwide, at least on the back of an envelope, it seems that most plants in the world are not run at this very high title, but there is capacity, although they are all available, all in a mode of constant production. So if you then accelerate and want to do more in protein, the bottlenecks will be in protein purification, and this creates a mismatch to the installed capacity that usually is installed capacity for a specific project. The other part is if you want to have more protein per amount, meaning you have higher, tighter processes, then again you get the very same mismatch in what has been established earlier. Here is a demonstration of history, what hadn't been feasible or thinkable at the time in the early 80s, that cell culture procedures could actually get very high. There are processes here that are in the milligram range, and that drive, if you need a lot of this, that drive the volume necessary for that. And these are usually for cytokines or sometimes for cell fusion. Whole antibodies are much better, and more recently, and if you see here, this is a 1, 2, 3, 4, this is 10 grams. It was alluded to before that the concentration of product in common manufacturing processes now can reach about 10 grams. I think 10 grams hasn't been reached for anything that's commercial yet, but it has certainly been reached for something that is in clinical trials. And so you can ask, if you have something from productivity, if the first generation gives you so much, or this is per day in harvest, and the second generation gives you that much, you want to know what to do with that, and then you can build either 6 more plants in order to do this without changing a process, or you can have a higher title and try to do the comparability study in order to get the same amount out of the plant that you have. But there are the limits, and the limits start in this sequence. There are first the tank sizes for product fluids, the turnaround time for individual steps because they're so much larger, the equipment size in column, and utilization of consumable and waters is at the very end. What the limitations is from the product's point of view is actually the stability and the solubility of the protein in question. These proteins, antibodies, have to be tested in not higher than about 50 or 80 milligram per ml, and therefore have an upper limit that you either provide the volume or you have to split it. And this is just a demonstration that always in one process you have something where it sticks out, and you need to have large volume if you keep it that way, and then suddenly plants should better be not named after the largest bioreactor, but after the largest volume tank for the downstream area. And so the combination of these trends for high titer processes with bioreactors is then going into smaller tanks, and these smaller tanks supply themselves in single-use tanks. This here is our attempt to put everything that used to be in steel, at least for the cell culture, into plastic bags and have it single use, and it works at least up to here. It's 1,000 or 2,000 liter, and the same is true for the downstream, where there are already lots of bags available, and it's disposable are the filtration, some of them at least, but the purification through columns are not quite disposable, so that the entire concept from A to Z, from the wall, the master cell bank or working cell bank vial to have this all disposable has yet, in my knowledge, not succeeded completely. The future needs and trends, where will the next limits be? In the near future, traditional antibodies will see improvements to meet increasing demand. This is a number of projects. This was alluded that more than 50% of the projects in clinical trials are actually somehow related to antibodies. Then there are the high titer processes. There is the evolution of the flexible manufacturing units that could then also appeal into regional centers. And there is certainly a regulatory adjustment on the move, dealing with biosimilars, but also in new markets in order to create either incentives or barriers for incoming technology and biologics, and the similar price and price competition. In the longer term, what I would think that will also need to be considered is whether, in addition to the antibodies, there will be scaffolds and scaffold binders that can then take a completely different manufacturing use that could outcompete. But so far, I haven't seen this. This is a plot to say a relationship between titer of a process and the need. And you can plot on this what facility may be good for which process. So you have the cytokines here, they are low in titer, they're low in demand, they don't need to, they are here. You have then more the onco-antibodies or antibodies and antibodies that are used a lot in gram. The titers of the original processes were higher, but not so high, so the volume had to be high, and that was the reason to create six-packs. We are going now with biosimilars and higher new antibodies, where it is a question whether then these biosimilars will also need six-packs, or whether they will be actually going into multiple single-use packs, or whether it, for clinical phases, is clear single-use is probably a good alternative. So in all, putting this onto the map again, we have a lot of area in the world where the smaller units can also now possibly find a home, while the largest will still be there where they are, and they will also probably have some local challenge with single-use or alternative manufacturing facilities. So, in summary, I believe that the industry has outgrown its large-scale rigid stainless steel capacity, and there's an excess capacity that still needs or asked to be used. And it is something like 50% is still interesting. These facilities will stay, and they will also probably perhaps get some more, because they will cater for the old processes where a comparability study for improvements is too expensive, and here the risk of quality and the effort for comparability or worldwide regular approval is just inhibitory. There's also, of course, intrinsically low-titer projects, non-projects like cytokines, enzymes, the hemophilia factor, some genetic substitution, and so forth, where this will require large capacities. Monoclonals represent an increasing sector of future protein drugs, and therefore the titers are increasing, and this will enable smaller scale, even so the total quantity of treatment may increase. Sorry. And so the single use is a possible way for flexible manufacturing based on the non-reusable equipment, provide a low-cost option. These will be qualified for market. I'm not aware that a therapeutic antibody is actually licensed in it, while I think vaccines are. And in individual emerging countries, this may enable local benefits, local labor, and because they are so flexible and without these upfront payments, they may actually then also forfeit the combination of worldwide manufacturing in single sites and distribute this over the regions where they are being needed, these manufacturing. Before the antibodies, however, are replaced by scaffolds, I believe that these scaffolds need to really come up with in the multifunctionality in the same way as being safe and efficacious as what we have in antibodies. Thank you very much.